We have some cool to build today. Let me give the rundown of what we're doing today. Today, we're gonna be building an ultrasonic vibrating knife that should make it easier to cut through things. We're gonna be testing on food. I probably should have brought it down in advance. I realized that I did not, so I'll have to head up to the kitchen once we actually have a prototype here. The main reason why I decided to do this is because I believe it's a Seattle-based company has just released a commercially available ultrasonic knife for like consumer production. And it is a $400 kitchen knife that has all the ultrasonics and the battery and everything in the handle. Very nice and compact, but $400. Basically, I was like, this is not new technology. You can buy ultrasonic transducers on the internet for a couple bucks. I've got ones of various sizes here, all the way from this little tiny one that's used for atomizers to this guy here, which is quite a beast, to this real big guy here. We can try it with a couple different ones. Especially with these guys, the little piece that locks into the center is interchangeable, so I'll be able to swap these out between each other. You can just buy these online, so ultrasonic transducing technology is not new by any stretch, but cramming it into a little knife handle is. Now, this guy in his like intro video has his whole thing where it's like, I've spent 20 years testing 10 billion transducers to try to find the perfect one in the perfect configuration. All right, maybe he's telling the truth. He seems like a fairly honest salesman. But I think that we could probably get like 50 to 80% of the way there for like 50 bucks or less instead of the $400 that his knife is sold at. Also, it's one of those startup pre-order now. Trust us, bro. There's never been a Kickstarter scam or anything before, so you can trust us. We'll definitely deliver in 1 year when we're done manufacturing them. But this is one that you can just make at home is the idea. So we're gonna be making our own ultrasonic transducing knife. I bought these cheap knives on Amazon. I got 3 of them for $7. Akuma, is this your knife company? It's a spinoff. It's a spinoff. It's called Kakuma. This is a genuine Kakuma knife. So we're gonna be making this out of the Kakumas. Mostly because I think I might need to like chop the knife off the handle to actually like make it transduce. Now I guess what I need to explain here is, why does having an ultrasonic knife matter? Like, what does it being ultrasonic do? And basically, you ever touch like the cone of a speaker? You touch like the cone of a speaker and it's going where it's buzzing when there's sound coming through it. That's because it's moving in and out really fast, right? And an ultrasonic transducer is basically the extreme version of this, where it's moving in and out really, really fast. So fast that you can't hear it, but it is a speaker. So it's oscillating back and forth very little, but really quick. This is why they use them for cleaners, because it agitates water very slightly, very fast. And it's able to cut like dirt and grime off of it. So basically the idea here is that if you have an ultrasonic transducer like this, and you have a knife coming off of it like this, where it's in line with the transducer body, it should, if you like, you know, get out a microscope and look at it, be oscillating back and forth like like an electric turkey cutter, really, really small and really, really fast, which will just make it slice through things easier. Pretty cool idea. And I'm pretty sure like dental tools and shit already use this tech. They use to clean your teeth. It's like a little pick that's like ultrasonic vibrating or something. It's already in place. Like, it's known technology. It's just that no one's ever made a kitchen knife that does it. Since it's in the news, I figured, why not take a crack at making my own, much less compact, much less attractive, but hopefully still functional ultrasonic knife. And we'll see how it turns out. Yeah, I gotta see if I can make the ultrasonic poop knife. Can we get a rules of nature edit for 1 cuts? Won't that get me demonetized on YouTube? It would be cool though. If you create ultrasonic toilet paper, would it keep it clean? I don't know. This is the shit I gotta deal with, man. I'll be real, when I ordered these, I thought they were the same size, and I was ordering a backup, because they weren't the same place, but I was like, oh, what if one brand's kind of shitty? I'll order this other one. It's probably the same part, but, you know, just to have an extra. Yeah, it turns out, no, this one's like way the fuck smaller than this one is. This is huge. Anyway, if I have this left over at the end, I should mount this in a toilet bowl and make an ultrasonic cleaning toilet, because that would be awesome. Also, this is gonna be pumped with this power supply that I purchased, because I didn't want to fuck with having to do a completely custom power supply. So I got this guy. It's a replacement for something, and it's made to drive this one, the smaller one. It's 110 volt at 40 hertz. That's pretty strong. I'm not really sure what the input is supposed to be on this. Am I supposed to feed like wall current into this? Or is it gonna step up DC voltage into high frequency, higher voltage AC? The idea is that this would be in a box and then there's a cable going to the, this is how we're making it not $400. Gonna have to make a few sacrifices if we want to make it in this world, brother. Why does it have a hole? Because in the original thing that this is meant to replace, I think that this is in the bottom. There's a basin of water or something on top, and then this shit goes here, and it's mounted to the basin. That's my guess. Maybe I'm wrong, but that's my guess. So for $50, it'll be wired. Yeah, it'll be wired into the wall as your compromise. Honestly, you might even be able to get it cheaper than 50 bucks. I only said 50 because this, with this transducer, was 40. And the knives were like $7 for all of these. These are really cheap-ass knives. Still, like, decently sharp. Even, like, a cheap knife is sharp. The difference between cheap and expensive knives is more just that the expensive knives hold their edge way longer. So if you spend a lot of time sharpening a cheap one, it'll be nice, but it'll fail, like, it'll start going bad pretty soon. Here's what I'm thinking we do for this, right? And it's a rough idea. This is a little more akin to how I used to do projects. I don't know, I still do them like this, where it's a rough idea and then we build off from that. So you see how they have this little thing that screws into the end here? This little nub? The other one also has one. They're the same size. We cut a slot in this little nub that screws into the transducer. Then we take our knife and we chop it short of the handle here, take the plastic off so we just have the metal, shave the metal down so it fits into the slot that we have cut into this, and then seat that up in there so that now it's fused to the knife. Maybe we can do some like brazing or something to get it in there. I don't know about that part. Affix it in some way, and then screw this into the transducer until the knife is connected via this, but also the bottom of the blade is touching up against the transducer flat. Then we build our handle out. We'll have to insulate the handle because this is going to be like a high enough voltage to zap us if we touch it. Build our handle out as a big, thick industrial handle that we can hold the chop with. And then that should be it. That also gives us the advantage that we could swap off the knife blade. So we could do our initial test with this one. And then once we've confirmed it worked, we could cut down the much bigger knife to be a more effective kitchen knife. We also have these little guys. This is a little atomizer transducer. I bought a pack of 4 of these because they were like $10 for a pack of 4. It's this little guy here, which is powered off a little USB-C, and then this little tiny transducer element. Why go through all this when you could just like spunk to the side of the knife? And the problem is that now the oscillation is warbling the knife this way instead of this way. You want it to be going, not, because that's going to make it cut worse. You need the oscillations to be in the correct direction, basically. On the back of the handle, then you're going to be holding this, and it's going to be, okay, if you hold a drill, If you wanted to make a spinning knife, you just attach the knife blade to the end of this, and then suddenly the knife blade spins, right? But if you're like, I want to take a rotating knife, I don't need to cut the handle off, just put the handle here, so then I hold it here. Now what's gonna happen? Is it gonna, no, it's gonna, this part of the drill is gonna spin around, and this part is gonna stay static because the anchor point is on the part that's supposed to be oscillating. So similarly with this, I think if I attached it like that, it would simply vibrate this part more than this part. Also, your hand would be going, Isn't what you're building just one of those electric turkey carving knives? Kind of, but no. We're building effectively like a strong version of that. All right, what power do I need to drive this thing? Because presumably this is handling the oscillation. It's got, what, 2 MOSFETs here? So this is probably a switching circuit that then is upscaling this. The question is this... I think this is a rectifier. We're gonna do some Big Clive-esque circuit analysis, but then I'm also gonna look it up to see if I've won, but I wanna make an educated guess first. Okay, so my guess is that the input for this thing is 120 volt AC, and here's why I think that. I think it goes 120 volt AC into this transformer. This comes out of the transformer, it's fused. These diodes, I think, are a full bridge rectifier, and this rectifies it into DC. That goes into this switching circuit here with these 2 MOSFETs. These take the 120 volts, which is now, because I'm assuming this is a 1-to-1, so it'll step it 120 to 120. This is a switching circuit that will switch it at 40 kilohertz for the output here. Okay, no, wait, actually, I bet this steps this down. Yeah, I'm rewriting a little bit here, okay? This steps it down into a smaller DC voltage so that these MOSFETs that are probably only rated for like 35 volts can do the switching. And then it goes through this to step it back up into 120 volts at 40 kilohertz. The board says 120 right there. It says 110 volt, 40 kilohertz. If you're gonna reading comprehension check me, at least like actually do it. 110 volt, 40 kilohertz is clearly the output. You are not taking 40 kilovolt input. And this is the out because it says out next to it. Well, you know what we should do is ground the knife. I hope this thing doesn't explode, because if I have to make my own switching circuit, I'm gonna be a little pissed. Now, it was very explicit, like, make sure you connect these to the right terminals, but these are not labeled at all. So what terminals do they want me to fucking connect it to, dog? Also, this transducer could very well, like, fucking torch out if we're not careful here. So I'll make sure, when we're testing it, I'll put this tin can full of water on the top. That should hold us, that should keep us in place. We gotta, like, mount this into something. Okay. Let me get my bench vise out real fast. Hang on a second. I'm trying to find... Why is this so hard to find? Ultrasonic polarity. They do not have a polarity. They are resonant devices. All right. Then the description was dog shit then. Excellent. Just what I thought, is that it's the piezo device. Why the fuck does it say... How does this even have a polarity? Is it like, is this like a flyback type of ordeal? I don't know, man. Fuck if I know, brother. I'll have to be careful with how I insulate this thing so I don't get zapped. This is what I was mixing the hot hands in. You know, never waste a good tin can. So this is basically how I'm gonna test this. Predictions for wet lab bench top. Solder this to the transducer here. Let's actually run this through a relay board. All right. Dude, what the fuck? This... What? That just came out of the... That's soldered on. Wait, why is that loose like that? Hang on, let me re-solder these terminal blocks. It's actually crazy that that just snapped, because there's solder cones on each one of these. Oh, it's solid now. The other one like that? No, just that end. That's weird. Love the vibro blades more than the sabers in Star Wars. I think it's probably based on this. These have been like lab equipment for a while, having like an ultrasonic blade. It's just that only recently that someone made a commercial product version. That's what inspired me to try to do my own version of it, basically. And then let's see here. Okay, wait, actually, yes, this guy. We're about to test this. I just want this relay board to be able to turn it on or off. I don't want it to just, as soon as I plug it in, be on. Also, I'm gonna plug it into the other outlet so that it doesn't blow my breaker. This guy shouldn't be a lot of power draw. It's more just, you know, if it's badly designed. Just glue a razor blade to the top of an electric toothbrush. You know, you say that as a joke, but that probably would kind of work. As long as you, like, got the grain corrected. Like, correct? This is a 12 volts, so let me run a quick little... I'll run this guy over here. This is like our activation wire. So this is a relay, which will, it's like a little electric switch. When you run a current through the coil, it'll contact the switch and turn on the much higher voltage. Because this runs on higher voltage, I want it to be fairly isolated from where I'm touching it. We're back to making things I can recreate at home. Yeah, I wouldn't recommend this one unless you kind of know what you're doing. I can explain this for like the curiosity of how the engineering here works. But yeah, this is a relay board switching the 120 volt AC to this. This is a power conversion board that steps the AC down to a lower voltage, rectifies it to DC. This is a switching circuit, which then turns it back into AC, but it's a much higher switching frequency of 40 kilohertz. And then this steps it back up into about 400 volts. And then that goes to the transducer here. So that's our circuit. I don't like that this is turning, but like literally I don't want to torque it down more because I'm afraid it might like crush it. We're attaching this so that it has a load. I don't want to risk it straight off the bat. And like, I already know it's designed for a water ultrasonic bath, so this should work as a functioning load. All right, so now pull this guy away. I can stand back a little bit. Let's go ahead and plug this in and see if it works right. I'm not saying I doubt that this is safe. I'm just saying sometimes it's good to take precautions. Shouldn't even be contact. All right, let's test. 3, 2, 1. Looks like it's working, man. You can see the water shaking too. It's definitely vibrating. All right, perfect. Now here's the question. Oh, I forgot I adhered it with a with tape. Said it wouldn't fall. I was gonna try to put something directly on the transducer to see what would happen. Looks like we got the bones of a nice working contraption here. Let's see what we can do with this, because if it works with water, it should work with knife. I might be fucked, I can't hear it. Can you actually not? I think it's as you get older, it's a lot harder for you to hear ultrasonic stuff. I heard it and I'm not wearing any headphones. Oh, it does depend on your speakers. That would be the more like damning thing it would show, is just who has speakers that have good enough spectrum. Yeah, you can't hear it on bad speakers. AirPods can't pick it up? Yeah, bro, I said bad speakers wouldn't be able to. Are these like the same nub? No, this one is like slightly longer, so this is the one that I want to go with, I think. I need to like lock it in. I mean, like, I think if you have AirPods, you know what you're buying them for. You're not buying them for exceptional audio quality. You're buying them because they're convenient and they sync to your phone nicely. The main reason you buy it is not because it's the highest quality, it's because it's nice and easy and it works with all your other shit. Which, there is something to that, man. We have this little nub. This screws into the end here. This guy goes here. We're gonna cut a slot into it so that the slot of the knife can fit in. Then we're gonna cut the end of this knife down to size and then fit it in there too, and then epoxy it all together. And then hopefully that creates a good enough bond for us to have our ultrasonic knife. We'll cut the slot here, see how well it fits this blade, and then we'll cut here and see if we can fit it all together. Hang on. What I thought was stable, it immediately started fucking... started fucking bending the minute that I started putting any sauce on it. I think that this might be too big and unwieldy, and we actually need to use the Dremel. Tragic, I know, because the Dremel sucks shit, but... How's this fit the knife? Not quite. Oh, that's actually good, because that means it can be a hammer fit. Yeah, we gotta chop the handle off one of these knives so that I can fit it into this little bit that I just cut. And then we'll screw that into the transducer, and then we can start working on some... Then we can start actually testing the damn thing. Imagine using such a small knife. You know what? You're actually right. I don't want to have to do this to 2 knives. Fuck it, we ball. Let's do it on the big knife. So then it's a proper kitchen knife after all. For this, we can use the big guns. the knife handle isn't, it's hollow? Ow, fuck, it's hot too. Was it too much steel to have the thing be solid all the way through? That's crazy that they would skimp on that. I wonder why, because like normally you would just put holes in the stretch of steel here, but they didn't even do that, man. Okay, let's clean up the edge that we've now bastardized on this blade. Okay, and this will need to be widened as well. There we go. Now it's starting to fit in the slot. Now if we just shave the side of this down, we can get to the point where we're gonna be able to hammer this on and really wedge it. Let's wedge this down. Oh, fuck. We just gotta really wedge it down in there. Okay, hang on. Let me take a little off the bottom. I think it might be... There we go. Ah, I cut my hand somehow. While messing with knives, say it ain't so. All right, see this? There's a 2-contact system where when you chop, it's connecting in 2 different places to resonate twice as hard. Can't wait for it to immediately fall off. It feels really secure now, honestly. Ah, fuck, man. Fuck. Did this, like, break in such a way that it won't fit in here now? Braze it as planned. I've already fucked this up by tapping on it so much. I've already fucked it up by hitting it with a hammer and cutting on it, and now brazing to it will really fuck it up. Heat this up with a torch and then apply some flux solder to see if it works. You know what? Let's try it. If I can get solder to flow, I'll be fucking shocked. I think the flux is not gonna be enough. Yeah, it's not gonna stick. It's gonna, like, shatter this knife or something trying to do this. While that cools down, I think of better ways to try to make sure that it stays mounted, because I'm sure it's gonna have more issues. Let's build up our handle here. Alright, well, this wasn't exactly what I was looking for, but we could totally pack it into this damn tube. So also making a scalpel blade, you need a huge metal cone to properly match acoustic impedance. Yeah, that's the thing that I'm concerned about, is the tuning. That's the thing that's going to be more tricky. It's not really the amplification. I'm getting enough power out of it. Trying to get like a resonance match is gonna be basically not possible. That's actually crazy that that fits like that. Okay, hang on a second. Let's make our handle real fast. We're also gonna need a little button in the handle for switching the blade on and off. It's not a toilet paper roller. It's way thicker than a toilet paper roll. Here's the thing is, even if this thing isn't in resonance, it can still have good results. It's just not gonna be as good results as one that's been, like, fucking tuned. Sorry, I have to make this thicker so that it friction fits in the fucking tube. Oh, now it fits a lot better, but it flops around because there's nothing to the sides of it to keep it from flopping around. Okay, hang on a second. We're really bringing us back to our roots here. We used to build shit out of cardboard all the time. Then at some point, I started thinking I was too good for it. Now we're making cardboard shit again. Alright. This will definitely work. Here we go. I mean, I bet it will, though. As jank as this looks. Here we go. People will say this is bad design, but this is awesome. Now, if I could just find my fucking, like, round button. Hang on a second. There we go. I knew I had one left. Yeah, this is coming great, actually. Hang on, we need something to help secure the blade. Alright, yeah, and then we'll shove this guy in. Well, first let's solder new leads on him and then shove them in. This ain't your mom's glue stick, okay? We're using the fucking yellow-ass, ultra-strong industrial hot glues. trigger that turns on the relay. I set that up earlier. All right, so now you press this and it... All right, I think it's fully heated. It's fucking smoking. Time to professionally mount this knife blade. You know, I think the thing that is the most defining feature of my channel is that it's the professionalism that I add to the builds. Nowhere else do you get to see real engineering like this, and that's just, it's so inspiring. That's probably fine. Well, I heated up fast. I'm realizing now, I really didn't make the knife cord long enough. It's only this long. I only have... I gotta do all my cutting like this close to the thing. Are you kidding me, man? That's real what I've gotta deal with here. Transducer will fly apart right after blade falls off. You know what, actually? I'm gonna let you put your money where your mouth is. Keep in mind, I'm not gonna cash this out until we've done a couple cuts with it. Let's see what you put on this one. I'm gonna say it now. Working supersedes all. If it is easier to cut with, and we get a couple cuts off, and then it breaks, the winner is work, not break. It's only if it doesn't work and breaks that break wins, okay? I'm giving you the description now, and I know you illiterate fuckers are still gonna not get it right. A lot of people voted for work / not break. So if I go to cut something and the knife blade immediately snaps off, it's gonna actually be over for everyone. If I break the knife while working on it, I think that counts as a break on the prediction, by the way. I'm gonna try not to break it at least. Have you played Deltarune? No, but I played Undertale back when it came out. It was good. I don't feel like the desire to play more things in the universe, I guess. Also, every time I see someone who's a Deltarune fan on Twitter, they're maybe the most annoying person on the planet. And it's just, you know, it's not like, I know not to judge an entire series or whatever by how people on social media who are into it act, but it does kind of make me go, like, do I really, like, am I really, as a 30-year-old man wanting to play this series that people are like having absolute bitch fits over like saying the character's name wrong in? Is that really where I'm at in my life? I don't think I am. Now, let's just make sure the knife functions. All right. Moment of truth. Okay. Okay. I can feel it in the handle. Well, it's definitely resonating. Okay, so we got something here. All right, now you can see this is not independent. It's connected to this over here. It works, man. It works. What can I say? To really see if it works, let me go up and get a cutting board and some food. Okay. This cabbage I got for the prison cooking is actually going to be pretty good for this. You can hear it too, right? When I turn it on. I like that it's not just on all the time. It is only on when I flick it on. I got these sweet peppers. You can see they're going a little wrinkly. Not quite got what they originally had. All right, see? Doesn't really cut very easily. Let's see if when I turn on the Vibra Blade, it cuts easier. Kinda? I mean, here's it without. It cut, wait, is it like, it's not as obvious as it should be, is the thing. That's probably because we're not resonant at all, and really the blade should be resonating with this, which would involve, like, tuning it and shit. And right now, we're using a blade that's fucking friction fit plus hot glued onto the thing. That feels like it cuts easier. Here's it without. And then here's it with. Dude, it helps it get through the skin a little better on this pepper. Ultrasonic placebo applies even to knives. I think it's placebo. You know what? I love how the placebos line up perfectly with the salty purple prediction scores on here. The thing is, it's hard to gauge because I'm having to cut it. Alright, that made no difference whatsoever. Cutting this cabbage does not make any difference. It has to, like, Oh, also, it's kind of come loose, so maybe that has something to do with it. A tomato would be a good test. I didn't have a tomato, that's why I used an old pepper. The skin of an old pepper is similar to a tomato, where it's like soft and it's gonna resist. There's no difference at all with the cabbage though, like for sure. We have this carrot here. Maybe there's some with this. All right, that cut pretty easy without it. Yeah, I can't tell a difference. I could say that there's a slight difference, but I think it's literally that it vibrates my hand a little bit when I activate it, and it just makes me not feel the resistance of the carrot as much. I think that's it. Ew, this pepper's moldy. That shit got fuzz on it. All right, well, we can use this to test. Like, I have to just saw it more with this. Hang on. Push down. Like, it literally won't cut while pushing. Let's see if it... I mean, like... Let's try to be as objective as we can. The thing that makes this tricky is it's all mushy and gross, because it's going bad. And it's got skin on the outside, and it wants to squish the skin. So here's... Okay, it eventually got through. Let's try it with the thing on, though. It's like the same. Push without. Push with. It's exactly the same on that. I can't tell any difference. It feels like there's slightly less resistance, but it really needs to be resonating, right? Cut on top of a scale to see the pressure. Oh, I see what you're saying. Let's see how this goes. This is a nice, consistent medium. And then let's see, hopefully this is consistent enough. 200, 900, 300, 400, 600, and... Oh wait, I cut all the way through it. All right, wait, hang on, let's try that again. It's like 380. 380 without the ultrasonic on. Now let's try it with the ultrasonic. Oh wait, hang on, I didn't quite catch it. It's literally like barely less. It's like 320. It's barely less. Okay, let's do it again. Unassisted. Unassisted, it looks like it's hitting like 380, 400, 380 to 400. And then, oh, it's probably hitting more because the knife's getting grimier as well. Then without. Yeah, it's like 340, 320, 340. It's barely fucking less. It's not worth it. It really needs to be able to resonate better with the knife. Also, it's getting fucking hot trying to do it because it doesn't have enough of a load. Yeah, so on one hand, you get this big, unwieldy knife, and you only, with a big power supply, chained to it via this long-ass cable. But you do gain like a 15% reduction in the push strength necessary to cut through a hot dog. I don't know, I'm thinking success, bros. I'm thinking success. Do the salt test like in the video. I don't remember that one. I do remember them putting it on a scale though. I'd forgotten until a chatter brought it up. The salt will display the resonance. I do remember that in the video. Damn, I should have just been referencing the video, man. Do you think the salt's actually gonna fucking jiggle? Yeah, is this gonna work or not? It's like barely shaking off the knife. It's just falling off. It's not doing anything. Hang on, see? I can tell you this, you can make this a lot cheaper. You can make this for less than 50 bucks instead of $400. So, you know. Was this project a fail? No, it was a cute win. It literally works. It just doesn't work that impressively. But it literally does work. If it was full tang, it might have worked better. Maybe. I'll show you a full tang right here, pants grab.